Okay, hello everyone. Welcome to this DCMI Best Practice Section 3. My name is Enxiang Liu from Oslo Metropolitan University in Norway. I'm moderating this section remotely from Denmark. And today, we will have 4 presentations, very interesting and timely topics for our meeting here. And the first one would be ontology design for supporting digital humanities on historical personages. The Taiwanese biological database TBDB case to be presented by Hao-Ren from National Taiwan Normal University. And the second one would be the guidelines for publishing structured metadata on the web to be presented by Mingfang Wu at the Australian Data Commons in Australia. The third one would be the linked data for the archives, models, technologies, and applications to be presented by Carla or Cristina. And the final one would be MetaWikiData, incorporating Wikidata into cataloging workflows to be presented by Ahava Cohen. And we haven't seen Carla and Cristina yet. So we will have a switch for the presentation order. So the linked data will be the last presentation, and then the MetaWikiData will be the third presentation. For each presentation, it will be about 10 minutes. And please type your question in the chats and during the presentations. And when all the 4 presentations are finished, we will have the Q&A sections. And first of all, I would provide an overview and join the themes from the presentations. And then I will check out your questions in the chats. And if you want to pose your questions online, please raise your hand, and we will give you the rights to speak. Yeah. So there's a case study. The first presentation, ontology design for supporting digital humanities, the TBDB case, to be presented by Hao-Ren from the recordings. Hao-Ren?
I'm Hao-Ren from Taiwan. I have pre-recorded my my presentation, so let me share the video. Oh, sorry. Again. Let me share again. Yeah. Hello, everybody. I'm Hao-Ren from National Taiwan Normal University. It's my pleasure to share with you our experience in designing ontology. This ontology aims for supporting digital humanities on historical persons and is applied to the Taiwan Biographical database. My presentation is divided into 4 parts. Introduction. Digital humanities can be defined as the use of digital materials and digital tools to transform scholarship in the humanities and the social sciences. History is one major discipline that has applied digital humanities methods. In history, person is a very important entity. The information on an individual's family background, academic achievement, professions, social status, kinship and social relationships, marriage networks, and political networks are essential clues for interpreting historical issues. Among many databases that collect information on historical persons, China Biographical Database is one of the most famous. TBDB is a cooperative project among Harvard University, Academia Sinica, and Peking University. As of this May, it has collected about 500,000 Chinese figures in 7th to 19th centuries. Following the idea of TBDB, we create a digital humanities-oriented system that helps historians discover information on Taiwan historical persons and explore research topics. This system is called Taiwan Biographical Database, or TBDB. TBDB collects biographies of Taiwan historical persons and offers historians several software services, including relational database search, full text search, text mining, SNA, information visualization, and GIS functions. As of now, TBDB has collected nearly 2,000 persons from 16 centuries, especially persons from 19th to 20th centuries. TBDB is available through the URL shown here. In the second part, I will talk about the development of ontology in TBDB. An ontology models the vocabulary and the meanings of domains of interest in a computer-usable form. The primary purpose of an ontology is to make knowledge reusable. An ontology defines the common words and the concepts used to describe and represent an area of knowledge. Specifically, an ontology will define the classes or entities, properties, instances, and the relationship in a knowledge domain. We follow the steps of Ontology Development 101 as shown here to develop the ontology in TBDB. The domain and the scope of the ontology is the biographies of the historical persons in TBDB. We consider reusing schema.org and the CDoc-CRM. Through biography full text, we can enumerate important terms to be included in the ontology. Then we can group those terms into classes and create control vocabularies. Take the biography full text shown in this slide as an example. We can find instances of persons, organizations, places, and professions. School is one kind of organization, and the political position is one kind of profession. In addition, properties of a class can also be elicited from the full text, for example, birth year and the death year of a person. Furthermore, we can also find kinship and the social relationship from the full text. So in this way, we can compose a biographic full text into this kind of diagram that illustrates class, instance, and the relationships. Through the analysis, we can define the properties of classes. As mentioned before, we try to reuse vocabulary terms from CDoc-CRM and schema.org. Here, we show the properties of person and organization respectively. We also group kinship and social relationships into a relation class. In this manner, we can populate the properties and the relations of an instance of a specific class. For example, here we show the properties and the relations of a specific historical person, Zhuo Jianguo. The properties of Zhuo Jianguo are shown here, and he has marriage and parenthood relations with other persons. After the ontology is defined and populated, we transform the ontology into JSON LD so that the ontology can become a linked data set. In the third part, I will give a quick system demonstration. This is the homepage of TBDB. A user can input person's name, person's birthplace, and the keywords in biography full text to search historical persons. Here shows the search result list. For each person, we will show his or her name, birth and the active place, and the type of persons, birth and the death year, and the source of the biography. Finally, the user can click here to see the full text of the biographies. We also implement the basic analysis function. Here is the full text of the biography of a specific historical person. In order to semi-automatically populate the ontology, we developed an algorithm that automatically recognizes persons, places, events, and organizations in the full text of biographies. We know it is very difficult to perfectly automatically recognize the relationship between persons. Therefore, we design an interface for experts to determine kinship and the social relationship. The interface will display the biography full text of a historical person, say A, and list all the names automatically recognized by the system from the biography full text. Then a historian can use the drop-down menu here to identify the relationship between the person here and the person A. So here, B is the firstborn daughter of A, and C has some social relationship with A. Currently, we are still working on creating the control vocabulary for representing different kinds of social relationship. We also developed an algorithm that uses OpenCV library to detect face from historical group photos. For example, in this historical photo, we can recognize there are two persons, but the system will false positively recognize a ghost face here. So a historian can upload historical group photo and input the metadata of the photo in Dublin code format. Then the system will detect some faces in the group photo, and the historian can identify the relationship between them. So from the identified social relationship, the system can conduct social network analysis like here. This slide shows another example of social network analysis. Recognizing that poetry clubs were an important kind of society in early century of Taiwan, we designed a function that illustrates the relationship between club members, places, and poetry clubs. And we can see from a place perspective, those historical persons were from this specific place, Lugang, and those poetry clubs were located in Lugang. In summary, in this talk, I present how my team follows Ontology Development 101 to create an ontology for historical persons and the application of the ontology in TBDB. The major existing ontologies reused are CDOC-CRM and schema.org, and we transform the ontology data into JSON LD for linked data. In the future, more instances will be created for each class, and we will attempt to develop semi-automatically algorithm to populate the properties and relationship of classes. In addition, because ontology development is an evolving process, we will keep refining our ontology. Last but not least, we will attempt to apply DC abstract model and the DC application profiles in our case. This ends my talk. Thank you for your listening. Hello, everybody. I'm Hao-Ren. So, hello.
Hello. Yep. Okay.
Yep. Okay.
Thank you, Hao-Ren, for your very detailed and good overview of the TDBD database system design and development through ontology. There are many interesting points there. I think that we will have more discussions after the presentation. Thank you. The next presentation let me see, will be the guidelines for publishing structured metadata on the web. It's particularly relevant to the schema.org and by Mingfang. Here's your floor. Mingfang?
Thank you, Yingxiang. Can you see my slides properly?
Yes.
Okay, cool. Hi, everyone. I am Mingfang Wu, working for Australia Research Data Commons in Melbourne. Today, I will introduce an effort to develop these guidelines for publish structured metadata on the web. So I will first talk a bit about motivation for this work, then introduce the guideline. So what's the motivation? In past a decade, we have seen increasing number of data repositories or catalog from public or domain specific. So that's good for open research and to improve research reproducibility. But this also brings the challenges with more and more data available through these distributed repositories. It's become harder for repositories exchanging metadata, as each repositories may adopt metadata schemas to meet special need of their repository and the user community. And for researchers, the public, it's getting harder to find the relevant data, especially when desired data is dispersed across several repositories. So here we're talking about a solution to meet the challenge, that is to leverage commercial search engines like Google, Yahoo, and Bing to facilitate broader discovery and access to research data. So we are doing this by markup metadata with schema.org vocabulary and publish marked metadata in metadata landing pages. So what is the structured metadata? And on these slides, the left is an example of metadata landing page that is markup with HTML tags for human to read. On the right side is the same information, but a markup with schema.org vocabulary that give us semantic meanings to each presented information as same information as on the landing page, but that's for machine to understand as well. So this structured metadata will be embedded in the same web landing page. So if there are more and more research data repositories publish these structured metadata, including that in metadata landing pages, that will greatly enhance the interoperability across data repositories. And the metadata across the repositories will be linked through the same property or related resource, then we can build a knowledge graph that on top of that, and this will enable innovative applications for discovery. And beyond that, this also provide a potential new method for repositories to exchange metadata. So here is an example, the use of structured data. So we can see information about two entities are already synthesized in one page that save a human being lots of time to synthesize by themselves. And here is example use of structured metadata. So when with this structured metadata, we can have a rich information presentation. And also, if one metadata record published into multiple repositories or catalog, as long as they have the same persistent identifiers, then their group can be grouped together. Not only the commercial companies can consume, web search engines can consume this data, as I indicated earlier. So we developed a prototype. We can harvest metadata across repositories as well. That saves us a lot of effort to maintain a lot of crossworks. So that was our motivation to publish structured metadata, and now I introduce these guidelines. So even though we probably people would think it's easy, just to adopt the schema.org property and encoding that in JSON-LD, but these need to be more interoperable. These need a consistent implementations across data repositories. So for that, we formed a research meta schemas working group from the Research Data Alliance platform to bring communities to exchange experience. For those who don't know RDA, so it's an international community-driven initiative for building the social and the technical infrastructures to enable open sharing and the reuse of data. So we hope this guideline will be useful for data repository operators, publishers, and aggregators when they publish and consume this metadata. And above all, that to improve the fairness of metadata. So in a nutshell, this guideline has 9 recommendations started from clarify the purpose. So why do you want to expose structured metadata on the web? What are your possible downstream consumers, and what do you want to achieve from that? And depending on your purpose, then you can identify what resource to be marked up. We highly recommend it to provide a persistent identifier to each resource and property whenever possible, because that's backbone to link resources and properties, similar properties. And once you know what to share, then the next step is to cross-work that map property from your resources to those in schema.org. And also for important to incorporate external vocabularies, if that can improve data discoverability and interoperability. Then next step come to the encoding this property. It's important that syntactic interoperability is as important as semantic interoperability. So there are examples for people how to encode those properties and be friendly to web crawler. After all, you publish this structured metadata is for web crawler to pick up and index them. And while you're doing all these steps, there are tools there to help you for mapping, generating, and validating. And then we also recommend to document and share each step, and that's important for periodical review and assessment, and for future improvement as well. Finally, last but not least, join a community and following established practice. So I give a little bit of detail of two recommendations. So one is the mapping. We collect 14 crossworks from general data schemas to discipline specific ones, and we align them up against the schema.org property. So in total, there are about 380 properties from 14 crossworks that are mapped to 41 schema.org properties. We classify these 41 properties by using the NISO metadata type. So so here, so for the Dublin core element, 15 elements, we only find the rise does not have a proper mapping in schema.org. People usually in data repository distinguish right, license, copyright, access right, and yeah, you can name them. And for the 15 DC terms, and there are 19 of them, we didn't find a proper mapping. And among them, like a has version, is version of, and a provenance that also in many other schemas like a DCAT and the data side schemas. That's important for us to track the data version process. One working group members also develop these visualization tools to help mapping. And the markup encoding in the guideline, we provide examples for some patterns. But for the complete list, more comprehensive list of markup encodings, we recommended the repository follow the ECIP guideline. So next step, that's the guidelines we developed that has been endorsed by RDA Council. So next step, we focus on the adoption of the guideline, test that with data repositories, and then revise them and improve the guideline. So yeah, so as I said, this work is carried out from the RDA platform. I would like to acknowledge the contribution of all members of this working group, especially my co-chairs and the co-authors of this guideline. And we welcome your contribution as well to further revise of this guideline. So that's the information. You can join the working group. We usually have a monthly meetings. Okay, that's all from me. And if I may, so because all people here are metadata practitioners or researchers, So on behalf of Professor Jane Gersborg and myself, I would like to invite you to submit a paper to the special issue Metadata as Data Intelligence. You can find the call for paper from the journal's website. Thank you.
Thanks, Min, for a great presentation about the community initiative for publishing the structured metadata to the web through the RDA, the research data alliances platform. I think that it's a good connections between the DCMI community and the RDA. In this kind of initiative. Okay, our next presentation, we have some changes. Our next presentation will be a co-presentation by Carla and Cristina from Portugal. Their presentation will be about the linked data for the archives, models, technologies, and applications. The floor is yours,
Okay.
Carla and Cristina. Thank
Thanks.
you.
Let me just share my screen, please.
Yeah, sure. Yes, we can see your
Yes.
slide now. Yes.
Okay, great. Let me just move this here. Okay.
Yeah.
Okay. Thank you. Good morning, everyone. I want to start by thanking the opportunity to be here presenting EPISA, a project run jointly by the Portuguese National Archives and 2 university institutions. The overall goal of this project is to connect archival records to the global linked data infrastructure, and in doing so, make archival assets accessible to a broader audience. My name is Carla Teixeira Lopes, and Cristina Ribeiro, that is also with us, is the other principal investigator of this project. So this project builds on recent views of linked data and their construction with ontology languages. Technologies are, of course, at the center of stage. They are recent, powerful, but still challenging to integrate and explore. So the Portuguese National Archives have a custom developed and very mature information system called the DigiTARC that supports description, reading room, preservation actions, and other management actions. The user interface of DigiTARC is used by specialists for remote work and by a growing community of citizens who explore the archives for personal projects. Back in 2018, the Portuguese National Archives started a dialogue with INESCTEC based on a view of the archives where a fine-grained and semantically rich model would replace the ISAD-based description system. The ongoing work of CDOC CRM with origins in the International Councils of Museums inspired this vision. An opportunity of a national call for data science and artificial intelligence in the public administration led us to organize this ambitious 3-year plan, including modeling, migration, and prototypes for a new archival information system. These pictures that we see here illustrates the vision for the new system and its relation with the existing ones. The Portuguese National Archives are the guardians of a national collection held in Torre do Tombo, plus 15 district archives and 2 specialized archives. One is a photography center and the other is an historic colonial archive. Current functions of the archive include archival description, conservation and preservation, and also digitization. And these functions will have to be supported in the future systems, but new functions might also appear. This central part of the diagram illustrates the evolution of the internal system from the current one to the new one. And we can see here that the interface will have to evolve according to the features of the new model. The link data will replace the ISAG representation, and information will no longer be stored in a relational database that will evolve to a graph database. From the user point of view, the existing interface where records are presented in an aggregate view will evolve to a more dynamic and fine-grained one, taking advantage of the explicit semantics of the new model. EPISA involves INESCTEC, that is the project leader, the Portuguese National Archives, that are the public administration partner, and also University of Évora, that has expertise in natural language processing. The formal budget is around 300K, but the real effort, if we count scholarships, the academic students and specialist collaboration, is equivalent to more than 3 times this budget. This project was designed to be run in 3 years, but given the contingency of the pandemics, we got an extension of an extra year within the original budget. As we know, the ISAG standard for archives accommodates units of description at different levels, from fonts to individual documents. ISAG description provides an uniform set of elements where some are more strongly typed, for example, dates, and others favor free text narratives such as scope and content or administrative history. And the transition to the linked data model creates an assortment of entities. Some of them are quite explicit in the existing records, and others require a systematic analysis to be extracted from the current records. And some examples are people, events, places, or professions entities. In this slide, we can see a sample death record in which we have the several fields. This one is scope and content. And in scope and content, we can see names of several people involved in this record. And here we can see the linked data representation that aims to atomize, explode such information into entities and their relationship. Each entity that is extracted is not only used in a single record, it might be used in other records. So now I will give the floor to Cristina to continue our presentation. Thanks. Cristina, you're muted.
Okay, now you see my screen, and I'm continuing in the line of what Carla was saying, our representation uses ontologies to capture the entities that Carla was talking about that will be considered in the representation, the properties that hold between them, and any constraints that have to be enforced. EPISA designed the so-called ARC-ONTO ontology, and we relied heavily on the CDOC CRM because it was a very mature model already, although we had to extend it with some new features to satisfy the requirements of the archives. For example, level of description is an important concept in the archives, and of course it did not exist in the CDOC. This is an example of record that has been represented according to this model. Each blue-topped box indicates an individual and a corresponding class, and individuals are related by properties, which are edges here, of course, and which are also defined in the ontology. So, for example, we have here a document, and you see that the level of description represented here, a title, an identifier, but also you can go into the details of the dimensions and the measurement units using concepts which are actually from the CDOC. Of course, this relies on technologies, and you can see here the components of the architecture which are implemented as containers. Apache Gina and Apache Fuseki are implement the triple store, and this is where all the graph elements are captured. The Angular framework is adopted to build the front end. And this architecture also includes a Postgres SQL database to take care of the administrative data regarding users, data configuration, etc. So this is a high-level view of this architecture. But based on this, we have this data flow view, where in the top line you see the flow of one of the tasks we have to perform, which is the migration of the existing records. It's more than 3 million records that we have to capture into the graph. And this goes into a triple store, and this is the first line of this data flow. On the bottom part, you see the app is a platform where you at the core is the triple store, but then also a connection to external resources, and this separation between the automatic migration and the platform is also a result of the fact that we are splitting work between groups here. And at the bottom, you have the two profiles that we are taking into account. It's the more technical profile of the archivists that have to describe new records, and also the public. And we have to take into account the many uses that the archives have currently. Here you can see just a screenshot of one of the prototypes that is under development. And this is just a search interface. Search illustrates the fact that various entities in the graph can be used to filter information for the users. So users do not have actually to navigate in that huge graph. They can have very specific interfaces, and we are exploring that as well in the project. Just to give you an overview of the team that is committed to this work. Inesctec is a larger team and is also the coordinator of the project. So we are in charge of the data model and the implementation of the platform. There is another team from the University of Évora, which is committed to the migration task, which involves parsing textual fields to extract the entities that are important to capture in the model. And we have the specialists from the National Archives, who in fact are very committed to this project, both as experts in the archives, but also providing requirements for the prototypes and evaluating the tools. This is just a short list of publications that have been made in the context of the project. And we had a very successful workshop at TBDB this year. So we were happy that many people from the digital humanities were interested in this topic and came to the workshop. And And more information on the project can be obtained in the project website. Thank you.
Okay, thank you, Carla and Cristina, for a great presentation about the initiative at the Portuguese National Archives about the development of a new archival system. It sounds like a really large-scale research project, and the ontology development in this short presentation. I think that they're similar to the previous presentations, lots of food for thoughts about the various semantic technologies to be used and implemented in this new system, and that's new potentials for the users to engage with the archives and the collections in new and very meaningful ways. So last but not the least, our final presentation at this section will be metadata Wikidata, incorporating the Wikidata into cataloging workflows by Ahava Cohen from Israel. The floor is yours.
Hi, I'm Ahava Cohen, the head of Hebrew cataloging at the National Library of Israel. A few background facts about our library. We were founded in 1892, long before the state. We've gone through a few permutations. We were established as a national library, independent of any other organizational structure in 2007, and we're now in the process of moving to our permanent home in the government campus next year. We have about slightly over 5 million print resources. We collect commercial music, self-published, games. Of course, we have archives, manuscripts, maps, ethnographic music. We're about a medium-sized national library, I would say. Because of the makeup of the population of Israel, we catalog in 4 different languages. Resources in Hebrew script are cataloged in Hebrew. Resources in Arabic scripts are cataloged in Arabic. Resources in Cyrillic scripts are cataloged in Russian, and everything else is cataloged in English. We use RDA, not the RDA that Mingfang talked about earlier, RDA, Resource Description and Access, the new cataloging rules, which incorporate CDUC CRM through the IFLA library resource model. And we code our information in MARC 21 using the Ex Libris ALMA cataloging and integrated library platform. The cataloging departments who work on the main stacks create about 4,000 to 6,000 new titles a month. We're about 40 catalogers, and each cataloger averages 2 or slightly more bibliographic records per hour, with a positive year-on-year growth in our collections and the amount of work we do, even though we have no staff increases. Our authority database is multilingual. As opposed to the cataloging bibliographic records where each one is in a specific language, here we try to coordinate all the languages that could possibly show up in our catalog. We call our authority database Mazal, Ma'agal Zuhuyot Le'umi, the National Authority File. It's also the word in Hebrew for luck, because we need a lot of luck to keep up with the work expected of us. Catalogers are expected to do 4 or more authority records per hour, unless they're doing bibliographic records at that time. We have over 1.9 million name authority files in our database, the majority of which are at least partially, if not fully, hand cataloged. over 1.3 million subject and genre terms, which are mainly copy cataloged or machine generated, over 200,000 geographic terms, the majority of which are partially or fully hand cataloged, and over 70% of our name authority records, which include Hebrew character access points, are multilingual and multi-script. Recently, an American cataloger said that the authority system we use is based on the principle that a concept or entity has one and only one authorized access point. In Israel and in Mazal, we utterly reject that premise. People in countries that don't use Latin character scripts are very used to living life with multiple authorized forms of their names in their local script, plus in Latin script for international use. And Mazal, our authority file, is built to overcome that Western and Anglo bias, which is inherent in forcibly Romanizing people's names. Our database is accessible to the public in multiple ways through the Israeli Union catalog. It's in the community zone of Ex Libris's Alma product, and it's also available through VIAF, the Virtual International Authority File. But that still keeps us siloed within the library world. And given the time and effort that we've put into building this database, we wanted to open it up to the world. We also wanted access to tools which aren't available within library systems. We have three goals in opening up our metadata. One is that RDA, the cataloging rules, allows and encourages the use of identifiers as preparation for a world of linked data. And we certainly don't want to find ourselves left behind as the world, especially the richer countries, moves ahead of us. We also wanted to open up out of our silo, out of the library world into the larger world, because we think our product, our database, is really excellent, and we want it to be used in more contexts. And even though we're a national library, or maybe because we're a national library, traffic to our website and to our catalog is very closely monitored. Opening our metadata boosts our ranking in search engines, and Wikipedia and Wikidata is a vital part of that strategy. So how do we do it? We have two main workflows matching the primary tools used in everyday work. Catalogers who create their records directly in the Alma N system do Wikidata work in-house. Projects and archives who mainly work on spreadsheets, which are then batch loaded into the main catalog, work with bulk tools like OpenRefine, and work in cooperation with Wikipedia and Wikidata volunteers. The catalogers work in three main ways with Wikidata. When we create new authority records, particularly if we've had recourse to Wikipedia or to Wikidata to help us disambiguate that person from another one with the same name, we will contribute back to Wikidata. Here, there's very little deviation from our regular workflow. The cataloger already has Alma and Wikidata open, so adding the property J9U, our system number, to Wikidata, and the mark field 0247 with the Wikidata Q number and a subfield 2 of Wikidata is the work of a moment. Depending on the cataloger, the complexity of the name authority record, and the commonness of the name, additional information may be transferred from Wikidata to the authority record. A handful of catalogers have been trained to work in Wikidata, and they can transfer information from the authority record back into Wikidata using the proper properties. A second workflow is part of the administration of the National Authority File. Librarians and public from around the country and the world contact us requesting changes to the database, merging multiple files for the same person into one, differentiating files, or just asking for enhancements. Each request is accompanied by a source of information, which more and more frequently is based on the world of Wikimedia. All of these requests are funneled to a handful of authority librarians, most of whom are experienced Wikidata contributors. Therefore, even though the starting point of the workflow differs from the first one, the endpoint is the same, a mutual enhancement of Wikidata and the authority record. I must take make it a special point here to thank Yossi Galron Goldschlager of the Modern Hebrew Literature Biobibliographic Lexicon, who's been a partner in this maintenance work, both when he was in residence here at the National Library as a Fulbright scholar, and now that he's back home. He helps us open up our data to the world through his lexicon project and the associated Wikidata entries. Another maintenance workflow is monthly rather than daily, and pertains to our participation in the Virtual International Authority file, VIAF. VIAF clusters together name authority records for the same entity across 40+ national libraries, cultural agencies, and other major institutions. This work is done programmatically, and because of different policies and decisions made by each library, there's a non-trivial amount of errors. At National Library of Israel, we manually reconcile hundreds of mismatches between our authorities and others each month, using the data contributed to VIAF by the Library of Congress, on the assumption that since NACO is one of the largest authority databases around, if we match them, we have a good chance of being included in the correct VIAF cluster. Still, we often find that after manual correction, the clustering has not improved. Sometimes it even gets worse. Here's where Wikidata becomes such a vital tool. As the staff of VIAF told us, Wikidata is a useful tool affecting clustering. If you want to split record A from record B, then you need 2 Wikidata records, one linked to record A and one linked to record B. Because cluster sanity will try to avoid putting 2 Wikidata records in the same cluster, it should help guide the algorithm when it splits up the cluster. If you want to join record C and record D, then you need 1 Wikidata record that links to both record C and record D. This makes sure that the records are linked together. It's not a guarantee because there's still other context, but it really does help. We also have to make sure that Wikidata doesn't have a separate record for a whole different person or other entity with the same name, because then VIAF completely loses the thread and doesn't know what to do. So we have to do a lot of reconciliation, not only on our database, but also within Wikidata to make sure that Milk and Honey, the American band, Milk and Honey, the Israeli band, and Milk and Honey, the cafe in Germany, don't accidentally cluster together and mess up the clustering in VIAF. Our last cataloging workflow is a contribution to Wikidata when we haven't used any information from Wikidata or Wikipedia, and we don't have any problems we need to resolve. It's just a matter of good citizenship. In this workflow, we identify a group of authority records we've worked on recently, such as adding Latin character headings to authority records for surats, and then we go down the list one by one, mutually enhancing Wikidata and our records. It might sound a little weird in 2021 to do so much work manually, but we find that it really empowers the catalogers, because one of the fears of library workers, particularly in technical services, is that if they're not tech heads, if they really don't feel computer forward, they're going to get left behind in a world of linked data. And these workflows help empower them by showing them that they have an integral place in the world of linked data, even though they're doing the work manually. We have a whole separate set of workflows for projects. These bibliographic and authority records are generated not by machine, not by handcrafting, and they're done in spreadsheets. They're done usually by staff who aren't trained in library methods. Therefore, we rely more heavily on technology and on tools and on the experienced non-library staff from Wikidata. One case in which we used OpenRefine and templates to create Wikidata entities was the Israeli Publishers Database. When we moved to Alma in late 2019, we decided that this database, which was maintained as a service to authors and researchers, wouldn't be incorporated in the main authority file. Using data dumps, OpenRefine, and student labor, we uploaded information about 2,000 publishers to Wikidata. We preserved that metadata for the future and gave our students productive work to do during the original coronavirus lockdown. Yesterday, DCMI hosted a panel discussion about metadata for cultural artifacts. Our visual culture projects are designed to document and make accessible Israeli architecture, dance, theater, and design by digitizing archives of creators and making the scans publicly accessible. The project has created a lot of authority records for people and corporate bodies who never have and never will produce bibliographic works. The records are created in spreadsheets by experts in these 4 fields, and they don't really know anything about library standards or archival standards. We then take these spreadsheets, normalize them a bit, but we batch load them into our catalog and send them to Wikidata volunteers who understand metadata better than the subject experts. And these Wikidata volunteers then add this information into Wikidata. Now that the global pandemic is turning into the new normal, we've taken a step back to evaluate the costs and benefits of our Wikidata workflows. On the cost side, we have mainly inconvenience. Catalogers' time is used for work which doesn't directly affect our catalog, and it also distracts them from their cataloging flow. There's also the cost associated with training them and retraining them as new properties are added into Wikidata. And it's especially onerous because we're talking salaries. It's not a sexy subject. It's very hard to get grants to pay people salaries for their everyday work. On the other hand, the benefits are significant. There's a perceptible boost to search engine visibility when our resources are exposed on Wikimedia projects, and providing structured data on Wikidata increases the likelihood that our metadata will be reused, upping the ranking of our metadata. Exposing our metadata also makes it easy for researchers to find and reuse it in innovative ways, once again reinforcing the search engine ranking of our library as an authoritative source. In our current COVID crisis, having a database which requires no paywall access, has a very low entry threshold, has proven key to providing employment for our less trained staff. Thanks in part to our Wikidata work, the library did not have to furlough anyone who wanted to continue working at home during the lockdowns. And of course, there's the benefit of preparing the way for linked data, which is approaching by leaps and bounds. But the true benefit, like the cost, is on the human and not on the computer scale, making our metadata part of the larger world, connecting us in a time of disconnect and reminding us that what we do has value and validity, because that's what we do. That's what we all do. Our work is to increase knowledge and to make that knowledge accessible. And in these troubled times, the benefits of connection, both within the library world and around the world in general, outweigh any of the inconvenient costs. Thank you.
Thank you, Hava, for a great presentation about the use of Wikidata, Wikidata in the cataloging workflow. I really enjoyed the presentation, particularly about the multilingual issues and the out of the silos of the cataloging world and the reuse of the metadata and to show the value of cataloging in this messy world at this moment. So let note, thank you everyone for a really inspiring and exciting discussions about the various issues about metadata. And I hope that we will have more discussions and collaborations or reading your papers in the near future then. Thank you everyone, and this would conclude our section today. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Bye-bye. Bye everyone.
Bye.